Hello guys, Dr. Toma here, and I've had a number of individuals ask me this last couple weeks about why in our office we draw more than just the TSH, or why doesn't their doctor draw more than the TSH when we're dealing with thyroid issues. We draw the TSH, T3, T4, TPO, and the thyroglobulin antibodies based on what we see going on with your health and what we believe may indicate that we need to do more. So I draw a simple picture showing individuals why we do those things, and I just wanted to draw it out for you at home so that you had a chance to either look over it again at your own pace or share with other individuals that may need help. In the simple picture that I draw, I tend to start out with a representation of the brain. And inside the brain, we have a small gland called the pituitary gland. And the pituitary gland is basically one that produces our master hormones. It's the one that tells the rest of our body what to do. It produces LH, luteinizing hormone, FSH, follicle stimulating hormone, prolactin, and it produces TSH, which TSH is thyroid stimulating hormone. It tells our thyroid, which is a small H-shaped gland in our throat, to produce T4. And T4 is a thyroglobulin complex with 4-iodine. So basically it looks something like this with 4-iodine around it. This is a carrier complex. It basically helps you move thyroid throughout the body without it being active and engaging with the cells. This T4 will go down to the liver, the kidneys, and the intestines. And these are the three main organs that turn T4 into T3. And T3 is a thyroglobulin complex with just 3-iodine on it. So it will have 3 iodine molecules fastened to it. This now is considered active thyroid. It's what plugs into your cells and makes their metabolism increase. Now, when this transformation from T4 to T3 is occurring, it can actually take off the wrong iodine. And in this case, we end up with what's called reverse T3. Reverse T3 may have a different iodine pulled off than that of the T4. So instead of having the iodine removed off the bottom, it's removed off the top. What significance this makes is when T3 is being plugged into a receptor site on a cell, that receptor site is made to only handle regular T3, not reverse T3. So when it plugs in, basically it has to have the correct iodine removed to function properly. When the wrong iodine is removed, it will not plug into that cell. So when we go back and we look at this whole process, our pituitary gland produces TSH, tells our thyroid gland to produce T4. T4 then goes to the liver, the kidneys, the small intestines, and produces T3. T3 then floats around the body as active thyroid and plugs into the receptor sites on our cells. And it tells our cells to speed up to perform its function that it's supposed to. Now, when you have T3 then comes back up and signals to the pituitary that T3 levels are adequate or significantly elevated or decreased. Now, the problem is your pituitary cannot tell the difference between T3 and reverse T3. So if the cycle is interrupted by the wrong iodine coming off, your pituitary cannot tell the difference, and it continues to produce TSH at the same rate it would if the whole thing was T3 and not reverse T3, leading to failures down the road to indicate what's going on if you only draw TSH. That's why it's important to draw TSH, T4, and T3. Now in our office, we also draw a TPO antibody and a thyroglobulin antibody. And the reason we do this is these two things tend to make a difference in how our pituitary gland receives the message of how much T3 is there and how our receptor sites on the cells perceive it. TPO antibodies are thyroid peroxidase antibodies. Thyroid peroxidase is the glue that holds the iodine to your cells. So the iodine and the thyroglobulin are basically held together with thyroid peroxidase. And when you have a thyroid peroxidase antibody, basically it gums up these areas. So when you come down to take off the iodine, a lot of times that thyroid peroxidase antibody will basically make it where you cannot get the correct iodine off of the cells, creating problems. It can also stick directly to the thyroglobulin, making it so the thyroglobulin does not plug into the cell receptor site, making it so you may have adequate amount of T3 and it may be the right kind of T3, but when you have a TPO antibody, it may not work in the receptor sites. The same thing goes for the thyroglobulin antibody. When we have a thyroglobulin antibody, basically we have a situation where the thyroid itself has an antibody stuck to it. And it can come in and stick directly to the thyroglobulin and make it so that the antibody doesn't allow the right iodine to come off, or maybe the iodine doesn't come off at all. You have a T4 floating around, your T4 numbers are high, but your T3 numbers are low. We can also have the same situation where it gums itself up and will not stick into the receptor site. And a lot of times, if we're measuring and we find out that our T4 is high and our T3 is low, we know it's a thyroglobulin antibody. In our office, we measure all of these indices so that we know exactly what's going on with your thyroid and we know what needs to be done to help you out. Many times it's things that we can do in our office. Sometimes we must refer you out to an endocrinologist to get some help with this, but at least we know what the problems are and we know what to do about them. So if you're in my office and you've seen this drawing, now you have it digitally and you can show other people. If you've never seen it before, you may have questions, reach out to us, or make an appointment at our office and we'll help you get your thyroid issues figured out. Thanks for watching this video. I hope it helps you tremendously know why we're doing the testing we're doing and also ask for the proper testing from other physicians out there. If you have any questions, again, make sure and reach out to us. But also, if you like this video, go and subscribe to Facebook, drop a line, let us know that you liked it and also what else you'd like to hear. Have a great day.